everyone. How are you doing? I hope everyone is doing good. So, welcome to another video of plant, water, and relation. We have almost completed the first part of the story, you can say, that is the mechanism of water absorption, different pathways of water absorption. Yes, now we will see how the water is translocated from xylem to different parts of the body. There are different theories which support translocation of water, root pressure theory, cohesion theory, capillary theory, transpiration pull theory. In this video, we will cover two, and the next two we will cover in the next video. Let's directly begin with the topic. As you can see in the photo over here, translocation of water. That is, once the water has been absorbed, how it will be transported to different parts of the body of the plant. Okay, so how does it take place? So this is xylem showing you transportation or transpiration of the water, and this is the phloem which conducts food. So xylem conducts water, carries and transports water. Phloem carries and transports food to different parts of the plant. Okay, so basically transport of water. Acha, when we are talking about water transport in plants, it is not pure water. Obviously, it will have dissolved minerals in it from the roots. Okay, that is the minerals from the ground surface. So from the root to different parts of the plant's body, like stem, aerial parts like leaves, branches, etc. And this will happen against the gravity. Okay, against the gravity, it is moving upward. So translocation against the gravity, or another very common term is ascent of sap. Sap is basically juice. You can just take a simple term for understanding. Sap is what? Juice. And in this juice is basically water plus dissolved minerals, etc. So ascent means moving upwards, going upwards against gravity. This is ascent of sap. Or in simple terms, translocation of water. Okay, this can happen in various ways. It can happen through the lumen of the conducting elements of the xylem. So if this is the xylem, you can see one cell, another cell, another cell. So through the lumen, like in between the cytoplasm, they will move up. Or the tracheids and vessels in all vascular plants. Okay, so translocation can happen through the lumen of the xylem or the tracheids of the phloem and other vessels in all the vascular plants. So several theories have been put forth to explain this mechanism, how the water is transported, translocated. Okay, several theories are there. Different theories have different understanding, different, uh, explanation that this is the way the water is translocated, or that's the way the water translocation, and every theory is having its own pluses and minuses, so that also we will be considering. So the first theory is the root pressure theory. Okay, root pressure theory. Another name is vital theory. Now what do we mean by this root pressure theory or vital theory? You can have a look over here. uh, the leaves are there, water getting lost due to transpiration. We have just covered this in the previous video. When there is high intensity of sunlight, or during the day, when the leaves are doing photosynthesis, so automatically some amount of water is getting lost through the leaf when they're exposed to sunlight. So what is happening? You can see water is moving up, right? Water is getting lost automatically. uh, the lower parts will demand for more water. The lower parts will demand for more water. So the water so there will be a pressure on the root. The root has to be, create that environment of continuous supply of water. Yes. So that is why the theory is telling you root pressure. Basically, this was proposed by scientist Presley. According to this theory, activity of living cells of root is responsible for translocation of water. So it's actually the root, okay, which is the main hero. You can say that. which is actively involved, is responsible for translocation of water. Though there are participants in the chain, leaf, then petiole, the stem, okay, all these things, but it's actually the root which will supply, which is responsible for the translocation of water. According to him, or according to his theory, what happens is, example, with the help of an example, is trying to explain us that when you take, when stem of a potted plant, you take a plant in a pot, which is with the pot, and you take that plant and you cut few inches above soil by a sharp knife. You remove the stem from that pot, okay, planted pot, and you just uh, cut the stem above the soil by a sharp knife, or just say you take a pot. This is the stem. These are the branches. Okay, and let's say you do a cut over here above the soil. Let's say you cut it from here. Xylem sap is seen flowing out. You will see. You might have experienced this also sometimes. You will see some whitish liquid coming out, oozing out through that end. Okay, you will see that the white sticky, maybe sometimes sticky substance coming out. Okay, this oozing out or exudation at the end, cut end of the stem, is a proof of existence that root pressure exists. There is this pressure which is created by the root, which is sending the ascent of sap, the sap, right? Xylem sap. Okay, we know now what is sap now. Water will dissolve minerals, the which is there in the xylem. So this is a proof that root pressure is existing. Just you are doing a cut in the stem just above the soil surface. Okay, so due to the pressure of the root, the theory is telling us, due to the pressure of this root, okay, water along with dissolved minerals is not only forced into the xylem, but it is conducted upwards towards the gravity. So it's not like just simply transportation is happening. It is helping the xylem to carry, to conduct this sap, this juice against the gravity. So this proves the root pressure theory is existing. So Jay Priestley tried to explain us his theory, his vital theory, through this example that this is existing. But there are certain drawbacks, you can say, not applicable to all the plants. Not applicable to plants which are very taller. In a potted plant, it's okay, but let's say 20 meters tall, so it's not applicable to those plants. Okay, then sometimes in absence of the root system, you will see ascent of root sap happening in certain parts of the fruit and the petiole and the branches and leaves, etc. For example, leaves also, if you will see, you just take a simple leaf and you cut the thick part of it, you will see some sort of oozing coming out. So there is no root system, but still you will see ascent of sap occurring. So this theory could not explain that. Then root pressure value is almost zero in taller gymnosperms. So similar, like taller plants, taller non-flowering plants, there are no pressure. Root pressure is not there. So does this theory applies to that? No, there is a limitation. Then plants who are actively, actively losing water, so there will be no pressure as such which is created in the root, so no root pressure will be developed. Okay, and usually the juice that we just when we cut the stem is under surface, is under tension. Okay, under normal condition, so it shows negative hydrostatic pressure or high osmotic pressure. That is, it is in requirement of water all the time. It's more requirement of water all the time. Okay, so all these points are like kind of an objection, you can say, that, oh, you said the Jay Priestley tried to explain his theory of root, of translocation of water because of the existence of the root pressure. But these are objections or limitations that does not have explanation via this theory. Okay, so We have another theory. Maybe some of these questions might be answered through this theory. So another theory is capillarity theory or the physical force theory, you can say. All of us are aware of this terminology. What is capillary, right? As you can see in this diagram, these are all capillaries of different shapes and sizes. These are thick. This is a bit thinner, and this is very thinner. The thinner the diameter, the more the water will rise up. Yes, you might have done this physical experiment also sometime at your home or in the college. So now, according to this capillarity theory by Boehm, physical forces and dead cells are responsible for ascent of sand. Now you see, in the previous theory, vital theory, there Jay Priestley was saying the activity of the root cells. Root cells are actively absorbing water and then they're creating a pressure, and that is how it is helping the xylem to translocate water and also conduct water to different parts of the plant. So actively living cells. Here capillarity, opposite. Dead cells are responsible for ascent of sap. There live living cells are responsible for ascent of sap. So this is talking exactly opposite. The conduction of water, now example here is given by this figure, you can say. Straw dipped in water. Let's say you have the straw of different diameters. You dip it in water and this water will automatically raise to certain height because of the capillarity, right? Now the height to which the water is raised depends on the diameter of the straw. So as we can see, the diameter will determine how much water will it take up. Okay. So this is simple to understand. Simple example. The thicker the diameter of the capillary, the amount of water that will raise, that will be less. So this capillarity, because of the physical force that's acting, because of the surface tension and the force of cohesion and adhesion between the water molecules. In the very first video, we talked about cohesion and adhesion, but still we will do it again over here. What is cohesion? Attraction between like molecules. And like molecules means, let's say, water and water. Cohesion. The attraction existing between water and water. And adhesion between unlike molecules. Let's say the wall of the cell walls and water molecules. The surface of the cell wall and water molecules. So these are unlike molecules. So attraction between them, adhesion, and water attraction between the like molecules. So this capillarity, this rising up of water is because of two physical forces, adhesion and cohesion, as put forth by the capillarity theory. Okay, so the theory tells us that here the capillary, the straw is comparable, like it's an example for the xylem vessel and xylem tracheides. So the xylem vessel are like example of the straw. The smaller the diameter, they will pull up water to that extent, and there is a force of attraction between the water molecules and also force of attraction like adhesion between the water molecule and the surface of the walls of the cell walls of the xylem vessel. Okay, this is what capillary theory tells us. Water column exists because of combined cohesive and adhesive force of water and xylem wall due to capillarity. So this results into the existence of the water column, and that is how the water is translocated from the roots to the xylem, and the xylem conducts it and transports it to different parts of the plant. But again, so this is how the cohesion and adhesion is telling you forces between like attraction between the water molecules, cohesion, attraction between the walls, unlike molecules, adhesion. Okay, so between water molecules, cohesion, xylem cell wall water molecules, adhesion. But again, these have again certain objections and limitations. The first objection or limitation is that xylem must be continuously and completely hollow from one end to the another end. But tracheids in the xylem show closed end walls. Tracheids are the part of the xylem which are not open free to free end. Like here also they are open and here also open. At some places they show closed end walls. So how does capillary theory explains that? In capillary theory, what did we just saw? That it has to be hollow to take water from here and conduct it from here end. But tracheids are closed end walls. The lower end of the capillary must be in direct contact with the soil. Yes, according to the example, what do we saw? This is a beaker, this is the water, and this is the capillary. The lower end has to be in contact with the soil or the water, you can say, with soil water. But there is a barrier. There is a barrier of root cortex. We saw all those now. Cortex, endodermis, epidermis, root hair. So all that barriers are there. So how do we give an explanation for that for capillarity theory? Then narrow the capillary tube, greater is the height of the water column. So this taller tree should show xylem vessels with very narrow bore, but there's opposite. Bigger trees have bigger xylem vessels, bigger diameter. So that's again a limitation. However, in nature, the taller trees show xylem vessels having wider bore. That is what I just said now. Bigger trees, bigger xylem vessels, bigger diameter. But what is the example that we saw right now is uh, thinner the diameter of the capillary, the longer the water column will be there. But in actual taller trees, opposite exist. So again a limitation, again a drawback, which capillary theory is not explaining. So capillary theory cannot be the only theory that we rely on. Like the earlier theory, vital theory, root pressure theory. So it is not the only sole mechanism. These theory might be existing. The water might be translocated sometimes in some way by the help of these theories put forth by these scientists, but not the only theory that we rely on. Okay, it's not the sole mechanism to explain the translocation of water, to explain the ascent of sap in all plants of varying heights. So that's all for this video. We have discussed the two theories, translocation of water with respect to vital theory and capillarity theory. Very interesting, and we saw objections and limitations to these theories also. In the next video, we will be doing cohesion theory and transpiration theory. Okay, that is the transpiration pull theory, another word for that. And we will also be covering how the mineral ions and food are transported. So cohesion theory, there we will be finishing with the translocation of water. Then we'll start with translocation of minerals and foods in plant. So stay tuned for interesting topics to come ahead. See you in the next video. Bye bye.